images or whatever it is. So how we can place it, how much data we are placing, so that all RAM memory devices are made up of electronics. Okay, simply you are calling the integrated memory chip. Memory chip is the one integrated circuit. So how we are manufacturing the memory chip using the electronics. Okay, using the electronics. Electronics, right? So now the basically these electronics are the semiconductors. Basically the electronics are semiconductors. How many you remember the periodic table in chemistry? The periodic table. Okay, in that periodic table, the many elements, the 150 elements are there. Right? How many total elements? 118 elements. So in that 118 elements, the total periodic table is divided into the periods and the groups. Right? So in that, some groups are called the we are using as a electronics. Okay, the electronics. Now, before getting into this topic, first, the basic electronics are semiconductors. Using the semiconductors, we are designing the electronic components like diodes, transistors, integrated circuits, any other components. Okay, so using the elements in periodic table. And the first one is how this electronic evaluation. Nowadays, you are heard about the word diode or transistor, right? The diode and transistor. Before the diode and transistor, the element is introduced in 1904. That is vacuum tube. The electronic component is vacuum tube, that is introduced in 1904. And the next one introduced, the next element is during our Independence Day, during the independence struggle, that is in 1945, the transistors. How many watched the English old movies? Old movies. So, see, if you want to store some data, they have seen the many, I think everyone knows the Telugu language, right? Yes, okay. ఓల్డ్ సినిమాస్ లో మీకు ఒక పెద్ద రూమ్ లో అన్ని వైర్స్ పెద్ద పెద్ద ట్యూబులు ఉంటాయి. ఓకే, సో ఓల్డ్ డేస్ లో మీకు ఇంత 1 MB డేటా స్టోర్ చేయాలంటే we have the many devices like half of the room in this. Okay, so in that time they are used the vacuum tubes. So the main drawback of the vacuum tube is the larger size. Okay, nowadays in mobile phone we are in the 2 years back we are seeing the 4 GB RAM. Now 8 GB, 16 GB also. But the mobile phone is the size is increased or same size? Same size or again the size is decreased somewhat thin. Mobile phone, older phone to new phone, but the features are high. So however, so in the olden days they are used the vacuum tubes. Now after that they introduced the transistors. Okay, this transistor is introduced by Shockley, the scientist name Shockley, and in 1947, these transistors are replacing the semiconductors, the semiconductor vacuum tubes. Vacuum tubes are replaced by the transistors. And after transistors in the 1947, the IC, the integrated circuits, and in 1952, the family of the large components inbuilt in the integrated circuit in the 1952. Okay, and in the 1970s, then here there is no vacuum tubes. After 1970, the device we are using in our life, that is the transistor. Okay, after that we are using, after 1970, the all electronic components are diodes and transistors only. So this is about the evaluation. So everyone knows we need to know about this electronics. Yes, sir. Irrespective of your branch, because without mobile phone we can't live today. Without laptop, without desktop, any electronic object, without, there is no human being. Okay, so now, so that's why we need to understand how that device are manufacturing, how the size is day to day, how the size is decreasing and the capacity is increasing, right? The memory capacity is increasing, but the size is decreasing. So how? Using these components, the diodes and the transistors. In the olden days, the computer is a memory device we are calling as a hard disk drive, HDD. The nowadays, that is called SDD, solid state devices, SSD, solid state devices. So the HDD size is the more and the SSD size is less because of the evaluations and the more introduced in the electronics. Okay, now and we are in the mobile phones. Without battery, it can work. So how you are charging the battery? We are not connecting always our mobile phone to switchboard. Okay, the switchboard is the uninterrupted power that will use the always power supply. If the power is there, continuously that will supply the power. But we are not connecting our mobile phone to switchboard. But we are in the mobile phone. How? Batteries. The mobile phones are having batteries. The battery is the energy storage element. So how we are charging the battery? Ella, how you are charging your mobile phone batteries? Chargers. That is called adapters. Okay. Now, is it that our mobile phone is the electronic gadget or electrical gadget? Electronics. So the all electronic device are required. The power supply is the DC power supply. DC, the power supplies are two types: alternating current and the direct current. So all electronic devices, including the TV, including this screen also, are with operating with the DC supplies. But the switchboard gives the which supply? The switchboard will give switchboard is the power item. Direct AC switchboard. This is the electrical component. The light is the electrical. So we are not using the any in between switchboard that switch to this fan. We are not using any other device. Simply connecting wire. That connecting wire passes the current from the switchboard to supplying the power from switchboard to fan device. But there is no intermediate device. Simply to transfer the power, we have the electrical wires. Okay. But if you are connecting the switchboard to our mobile phone, in between we are using the adapters. So how the adapter is completely today, you can understand the how adapter is working and how the mobile phones are our electronic gadgets are works. Okay. Now see, after this evaluation, now directly we are entering into the subject, that is the semiconductor devices. This all are comes under the semiconductor devices. So how the semiconductor devices we are manufacturing and how we are using to manufacture this diodes and transistors and integrated circuits or whatever. Okay. Now, semiconductors. In periodic table, the third group, in periodic table, basically these semiconductors are divided into pure semiconductors, impure semiconductors. The all third group, fourth group elements are called the pure semiconductors. The two pure semiconductors are called the intrinsic semiconductors. Intrinsic semiconductors, and this one is extrinsic semiconductors. So all four group elements are the pure intrinsic semiconductors and the impure semiconductors. And this all examples are pure semiconductors are all fourth group elements. That all fourth group elements are silicon and germanium. The silicon and germanium. Now tell me what is the anyone atomic number of silicon and germanium? 14. Which one? Silicon is the 4. 14 is the atomic number. Next, what is the noble gas nearest to silicon? Noble gas. Argon. What is the atomic number? 18. Before 18, what is the another noble gas? Neon. What is the atomic number? 10. So the neon atomic number is 10 and argon atomic number is 18. 18. What is the silicon atomic number? 14. In the all in this fourth group elements, the 14 means here there is a chance of, so the 14 are called valence electrons. Okay, every atom, that is a germanium or silicon or aluminum or boron, phosphorus, any element in the periodic table are having the atomic numbers. Okay, the unique atomic numbers, and based on the unique atomic numbers, that elements are having the valence electrons. What is the meaning of valence electrons? It's having the neutrons and the electrons, photons. Okay, now the electrons. That means here the silicon is the near to, for example, neon. Neon is 10. So the 10, this is the atomic number is 10. So the any element, the noble gas entity, we can't break that elements, the electronics. So the neon is having the 10 atomic number means it is having the number of electrons are 10. The all 10 electrons are in bonding only. So we can't break that bond. That's why the neon and the argon are called noble gases. Neon and argon are called noble gases. Okay. So these noble gas electrons we can't break. Already that is in the strong bond. Now coming to the silicon and the germanium, the silicon atomic number is the 14. That means that is having this 10 electrons, and this remaining 4 electrons are the valence electrons. That valence electron can donate or can. So if it is donating the 4 electrons, then how many electrons with silicon? 10 electrons. So the 10 electrons are like neon. So noble gas, that is the, we can't break the 10. But out of 4 is there, that 4 can donate. So after donating the 4, మన దగ్గర 14 rupees ఉన్నాయి. 4 rupees donate ఎంత ఉంటాయి ఇక్కడ? 10. So donating means that is called the donor. And if it is accepting 4 electrons, then how many electrons with the silicon? 18. So that is called the acceptor. Okay. So to form the acceptors and donors, then that intrinsic semiconductors are not pure conductors. What is the meaning of conductor? What is the conductor? Which allows the flow of electrons. We'll get the shock. How we are getting the shock? Electrons are flowing from that way to our body. So that's why we are getting field shock. Okay. So similarly, here the pure semiconductors are not conductors, pure conductors. Okay. So here what we are going to make? We are going to make the semiconductor should be conductor. How we are making the conductor? By adding impurities. By adding impurities to that pure semiconductor, we are getting the conductivity. We are increasing the conductivity. That elements are called impure semiconductors or extrinsic semiconductors. The extrinsic semiconductors. What is the how we are making the extrinsic semiconductor? By adding impurities to the pure semiconductors, the impurity or extrinsic atoms can generate. Okay, so why we are making the extrinsic and intrinsic semiconductors? Because to improve the conductivity of that material, that atom, to improve the conductivity of that material, we are adding impurities. That impurities we are adding to this fourth group elements are the fifth group elements or the third group elements. Now we are calling in the periodic table the third group elements and the fifth group elements are called impurities. The third and the fifth group elements are impurities and the fourth group is the pure semiconductors. So for the pure semiconductors we are adding the impurities. The impurities are third group and fifth group. Okay, in the third group elements, how many valence electrons are present? Three valence electrons. Tell me the one third group element. Boron. The boron atomic number is 5. Near to 5, the noble gas is helium. The neon ekada 10. Helium 2. So distance is 3. So that boron is near to helium, not neon. Okay. So the 3 valence electrons. So if that boron is donating the 3 elements or 3 electrons to the another one, that is in the same side. Okay, in the noble gas. Okay, without breaking the remaining 2 elements, 2 electrons. And similarly here also we are to make the impure semiconductors, we are adding the impurities. That impurities are, for example, third group. Based on this elements, P-type, the extrinsic semiconductors are the P-type semiconductor and the N-type semiconductor. Extrinsic semiconductors are 2 types, P-type and N-type. Is it visible for last benches? Okay, N-type semiconductor and the P-type semiconductor. In N-type semiconductor, by adding pentavalent, what is the meaning of penta? 5 valence electrons. The which elements are having 5 valence electrons? So that atoms are called pentavalent. Okay, pentavalent. So now if you are adding the pentavalent atoms to the pure semiconductors, then that forms a N-type semiconductor. Okay, so now how we are adding the impurities to the pure semiconductor to increase the conductivity. Okay, so now you can take the one N-type. First, we'll take the N-type semiconductor. Tell me the one N-type pure semiconductor. Let's take the germanium. Okay, the germanium is having how many valence electrons? germanium is having 4 valence electrons, or I will keep the star. Okay. Now, to in forming the adding the impurities to the pure semiconductors, these 4 valence electrons of germanium is forming a covalent bonds with the impurities. What is the impurity? Pentavalent. Tell me the one pentavalent element. Nitrogen. Then okay, phosphorus. Phosphorus is having how many valence electrons? 5. The 5 are this. Okay, now here this germanium 1 valence electron and phosphorus 1 valence electron is forming a covalent bond. Right? Another germanium here is forming another covalent bond, and here one more germanium is forming the another covalent bond, and here one more germanium is forming covalent bonds. Now, so this is called this combination is called the extrinsic semiconductors. Okay, now the phosphorus is having, listen carefully, the phosphorus is having the 5 valence electrons, right? And germanium is having only 4 valence electrons. These 4 valence electrons of germanium are forming a 4 covalent bonds with phosphorus valence electrons. Right? The phosphorus is having the 5 valence electrons. Out of 5, the 4 valence electrons of phosphorus are forming a 1 covalent bond, 2, 3, 4. The 4 covalent bonds. Right? So now again the phosphorus is having the one more valence electron. Okay, that is the excess electron. Now the electron is, what is the charge of the electron? Minus. That is negative. So that's why this type of semiconductors are called N-type semiconductors. Now the N-type semiconductors are having, what are the charge carriers? Electrons. That is the minus. Minus means electron. So the electrons are charge carriers. Now if you are applying the power to that semiconductor, that's the impure semiconductor, the electrons can move from one place to another place depending on the power supply. So any power supply is having the 2 terminals. What are the 2 terminals? Positive and negative. That's the DC supply. Okay, positive terminal and negative terminal. Based on the connectivity of that power supply, that electron can move from one place to other place. That is the one direction to other direction. Right? So that's why because of this excess electrons, this impure semiconductor is called N-type semiconductor. Right? N-type. Next, coming to the P-type semiconductors. Now you can take the one P-type, same element. Germanium is having the 4 valence electrons. Right? Next, you can take the phosphorus. What is the? Shall I take the aluminium? Aluminium. The third group or fifth group? Third group. Okay. The third group means that is having the valence electrons are 3. Right? So now here this can form a 1 covalent bond here. The one more germanium valence electron can form a covalent bond, and here one more germanium can form a. This is the continuous process. Here empty on the electron on the, this electron is forming a covalent bond with another phosphorus element. Right? Next, here also same. Now here one more germanium. What is this? The aluminum is having the 3 valence electrons. Right? The 3 valence electrons. The 3 valence electrons are forming a 3 covalent bonds. 1, 2, 3. The 3 covalent bonds with the germanium valence electron. But the germanium is having the 4 valence electron. But the 1 excess electron is there with. But if the phosphorus, no electron. So simply empty. Right? So this is called holes. Holes and we can accept that is required the one electron to form a covalent bond. So now this, if you are making this bigger structure, the large structure for this impure semiconductor, then what are the free charge carriers are present in this structure? Holes, number of holes. It will be continuous. The many phosphorus, many germanium and many aluminum elements are there. So by forming the many elements, then the each bond, each aluminum is having the one space, that is called one hole. Now this p-type semiconductors are having the charge carriers are holes. Now and here electrons. The electron polarity is negative and the hole polarity is positive. The electron polarity is negative and the hole polarity is positive. Okay, so these are the impure semiconductors. Using this impure semiconductors, we are studying in the introduction. There is the transistors, diodes, integrated circuits, and the memory devices. All can be making up using this semiconductors. That is the impure semiconductors. So why we are making the impure semiconductors? To improve the conductivity of that material. Semi and enti off. That fourth group elements are. So to improve the conductivity, we are adding the impurities to the pure semiconductors. That making the impure semiconductor, that is called the extrinsic semiconductors. That based on the impurity, which impurity we are adding, based on that concept, the semiconductors, the impure semiconductors are N-type semiconductors and the P-type semiconductors. Now in the N-type semiconductors, these electrons are called charge carriers. Charge carriers, that means carrying the charge. The which charge it is carrying? Electron, negative charge. And these holes are also called charge carriers in the p-type area. The which charge is carrying? Positive. If anybody wants to know that, you can know that. Okay. Now this is the introduction to our semiconductors. Okay. Now the semiconductors are two types: the pure and the impure. Impure allows only by adding the impurities. Then the two impure extrinsic semiconductors, that is the N-type and the P-type. Using this N-type and P-type, we are making the diodes and the transistors. Anybody wants to note down? You can note down. This is the introduction. The next topic onwards, actually we are entering into our actual content. In between, if you are getting any doubt, you can ask. Next, the voice is audible. Is it clear? These all concepts, I think you already studied in the intermediate physics. Next two. Yeah. Periodic table comes in chemistry, but semiconductor concept in physics. Semiconductor. Okay, next. First one is N-type semiconductor. Now just I draw the one block for this N-type semiconductor. So here, this is the N-type semiconductor, and this is germanium plus impurity. The pure semiconductor plus impurities we are adding. This impurity is the fifth group elements, right? And this one is the fourth group. Simply by adding the fourth and the fifth group, they are making the N-type semiconductor. Now this N-type semiconductor is having the charge carriers are electrons. The charge carriers are electrons. Now, the charge carriers means excess electrons. Any device is accepting the requesting the electrons, then you can donate this electron. So after donating this one electron, here electron one space that is called the positive ion. After donating the one electron, here, that is calling as a ion. That ion is the positive ion. This is the electron, and this one is donor ion. Last pen size martala. Okay. Now the N-type semiconductor. This N-type semiconductor is having the charge carriers are the electrons, right? The charge carriers are electron. Now, if you are applying any power supply to this, or if you are here, this is having the charge carriers are electron. If after donating the one electron, then that is forming a ion. That ion is called positive ion. That is the donor ion. So now this is called donor ion, and this one is electron. Is electron. Okay. Now, okay, the donor ion. Now we can take the p-type semiconductor. Same. The p-type semiconductor is having the charge carriers are holes. The holes are denoted as the positive sign. Okay. After accepting. Okay. Now, for example, if you are joining the p-type and n-type. N-type is having the charge carriers are electrons, and p-type is having the charge carriers are holes. Now that hole is accepting the excess electrons from N-type semiconductor. Now after accepting, then what will happen? The covalent bond will form. Okay, that means the electron is moving. So now after accepting the one electron from N-type semiconductor, then that is forming a ion, that ion is called a negative ion or acceptor ion. So now this is called acceptor. It is called acceptor ion. Now, so this is about the N-type and P-type semiconductor. Now, the next one, if you are joining the P-type and the N-type semiconductors, if you are joining the both, is the P-type semiconductor and N-type semiconductor, if you are joining both, so simply you can join both N-types pure impure semiconductors. Okay. Now we are not connecting any power supply. Simply we are joining the N-type semiconductor and the P-type semiconductor. The N-type semiconductor is having, this is the P-N. P, this is the N-type. So N-type is having charge carriers or electrons, and this one is having the charge carriers is right. Now, so which electrons and holes are nearby by joining the P-type and N-type semiconductors? Now, the excess electrons from the N-type semiconductor is ready to donate the electrons. Okay, now, and this P-type semiconductor is accepting the electrons from. So now, after donating the one electron, then that is forming a donor ion. After accepting the one electron from the N-type semiconductor, this is forming a covalent, then that is called the acceptor ion. So now here, this is negative, this will form a positive, and this one is negative. Right? Now here, the electron is, the N-type semiconductor is donating the one electron, then that is forming a donor ion. Now this electron is accepted by the P-type semiconductor, and this is forming a acceptor ion. And similarly here also, okay, now listen. Now after, this is called the P-type PN junction diode. How we are making the PN junction diode? By joining the P-type and N-type semiconductor, we are making the P-type PN junction. Okay, PN junction. Why we are calling the PN junction? An ideal state without applying the power supply. Here, this electron, this N-type semiconductor is the donating the one electron, and this is accepting, and this one is donating this one, and accepting, donating and accepting. So after donating and accepting the electrons, here some barrier will form. Barrier, and it is some wall, some obstacle. So after forming the barrier, no electron can pass from N-type to P-type semiconductors. And the ideal stage lo unna మనం ఇక్కడ ఎవరన్నా ఉంటే we can attract. After attract అయిన తర్వాత వాళ్ళు ఇంకా నెక్స్ట్ అతను ఇక్కడ నుంచి ఇక్కడికి వెళ్ళడానికి స్పేస్ ఉంటుందా, వీళ్ళ మధ్యలో ఉంటారు. So that is called the barrier. So after developing the barrier, the no electron is crossing from N-type to P-type, and the no hole is crossing from P-type to N-type. So the barrier is developed because of the barrier is developed. Okay, so after this barrier is called junction. Okay, that barrier is called junction. So the device named as a PN junction. PN junction. That barrier is called PN junction. That means the between the p-type semiconductor and n-type semiconductor, the barrier is developed. So because of that, we are calling this is the PN junction. And this PN junction is having the two terminals, then the positive and the negative. Okay, the two terminals. Now this device is called PN junction diode. The device is called PN junction diode. So now how we are making the PN junction diode? By joining the p-type and n-type semiconductors, and at ideal state, some electrons are donating from the n-type to p-type, and the p-type poles are accepting the electrons from. So after accepting and donating the electrons at the poles, then some barrier will develop. That barrier we are calling as a junction. So now that is called the PN junction diode. Type, what is the type? Two ions. What are the two ions? The positive ion and the negative ion. So that's why that device is named as the PN junction diode. This is the basic electronic device for the all other high-end electronic components. Okay, so this is the basic, the PN junction diode. So how we are making this concept? Okay, now this PN junction diode. So that is the, and if you want to know the symbol of this diode, the diode symbol is one arrow, right? And arrow with two terminals. What's the direction of this? This direction shows the flow of current. So this is the anode, and this one is cathode. The anode is the positive and the cathode is negative terminal. And one more here, some junction is, this is the p-type and this here n-type. But in between the p-type and the n-type, some barrier is there. That barrier we are denoting as vertical line, that is called the junction. Okay. So now the PN junction diode, the symbol. That arrow shows the conventional current direction. With respect to electrons, what is the current direction? With respect to electrons and holes, what will be the current direction? I think you studied the electrical. What is the current direction? When it is positive and when it is negative? Here the holes ఉన్నాయి, ఇక్కడ electrons ఉన్నాయి. What is the current direction? Holes to negative. The always how the electron is moving here? Electron ఎక్కడి నుంచి పోతుంది? N type to P type or P type to N type? Electron. How the electron is moving? Electron. The N type semiconductor is the charge carriers are electrons. These are the excess electrons. Now this excess electrons are donating to P type to make the covalent bond. So what is the direction? Electron direction? N type to P type. Now coming to the current direction, always the current direction is opposite to electron direction. Fishes ఉంటాయి కదా? How the fish is moving in water? Opposite direction. Here also same. You can think the current is the fish and current is water and electron is fish. How the fish is moving? The opposite direction to water. And here also the electron is moving, current is moving opposite to electron direction. And current is the same direction as pole direction. You can remember this. So that's why here this is the P type semiconductor and here we are taking the N type semiconductor. So the electron is a charge carrier. Now this electron is moving from N type to P type. So therefore the current direction is this. So in the diode symbol, arrow shows the conventional current direction and the vertical bar indicates junction. So this is current direction, I direction. I stands for current and this one is photo. junction, formation and symbol of PN junction. Diode. If you have any doubt in this formation, I will explain once again. Now, working operation will understand clearly by connecting the battery to that PN junction. How the current is moving, we can understand clearly in the operation of the PN junction diode. You can take the one plastic chain, you can connect the one wire here, you can touch here, you will not get shock because the electron is not moving from this place to this. This is the insulator. The chain and the wood are insulators. If you connect the one end of this podium, you can connect the one wire to this podium and you can touch the top, you will not get shock because the electron is not moving from that end to here. So that's why we are not getting shock. Okay, the current is nothing but the flow of electrons. Electron flow untune current untundi. So that's why we are defining the current is the flow of electrons, and the direction of current is always opposite to electron direction. Okay, now everyone listen the operation of the PN junction clearly. The rest of the topics are easy. After PN junction diode, then the transistors are there. The transistor working operation is, if you are not understanding this PN junction diode operation, that is, we can't understand the transistor operation. Both are interlinked. Okay. PN junction diode operation. Okay, now you can take the PN junction diode construction diagram. The p-type semiconductor and the n-type semiconductor equal amount we are joining. If the bit the same bit you can draw the n-type also. Okay, that is the p and n-type. Now the p-type is the charge carriers are holes. Okay, now you can take the two terminals. This is n-type is cathode and this one is anode. Now you can take the one battery. What is the battery symbol? Anyone show me the battery symbol? Just in draw structure. Correct. So this one is the battery symbol. That means we are connecting some external battery to the PN junction diode. This is the PN junction diode. Okay. Now you can connect the power supply. That is the battery. The battery is at the two terminals. One is the positive terminal, negative terminal. One side you can connect the positive terminal. Other end of the diode you can connect the other terminal of the battery. Okay. So now what this large vertical line and small vertical line indicates? Positive. This is the symbol is the battery symbol. Battery positive terminal, battery negative terminal. Okay. Now you can join the. This is the operation of the PN junction diode. Okay, now you can connect the positive terminal of the battery. You can call it as a battery. Positive terminal of the battery to the P-type semiconductor, and the negative terminal of the battery connected to N-type semiconductor. Okay, so this is the construction and applying the power supply. Yes, applying the power supply to PN junction diode. Now I am not switched on this battery. Battery is the off position. Battery is off. Now I am making the positive terminal of the battery to anode, and the negative terminal of the battery is connected to the diode cathode. If you want, I will rather using the symbol also. Using the symbol, this is anode, cathode. What is the cathode spelling? Cathode, but we are abbreviating as K. Don't get confused. The anode is same, ANODE, right? So anode is represented as A and the cathode is K. This is the negative and this is the of the diode. Okay. Now we switch on the battery. Listen carefully. Switch on the battery. Now the battery positive terminal to P-type. Already in the ideal state, here we are forming a one barrier. The dotted line shows junction. What will be the dotted line? What is the meaning? Continuous line show dotted lines. Traffic signals low. Continuous line untadi, some brake line untadi. Continuous line means don't brake, don't overtake, don't cross that line. Right? Don't cross that line. Ante ee line lo pote atte lochu ite same line you can use. That is the continuous line. Brake line means you can overtake. Mundodu slow unte you can overtake that line. You can overtake that breakage. And here also the dotted line means if there any chance you can decrease the barrier, okay, or you can increase, you can decrease or increase. How that will happen we can understand now. Okay, now I am switching on the battery. Battery is you can do the supply. For example, you can take the 5 volts. Now this 5 volts we are connecting to this positive terminal. Now what is the battery terminal? Positive. What is the P-type semiconductor charge carrier's polarity? Positive. Now what will happen? Positive and positive repels according to the magnetic principle. How the south pole and south pole will repel, the north and north will repel, and similarly here also the positive terminal of the battery and positive pole of the P-type semiconductor can repel. Now after repelling this pole, what is the old direction? What is the old direction? Towards N-type semiconductor. So the hole is moving like this. Hole is moving. This hole is moved towards here, and this hole is moving towards here. This hole is moving towards here. Now you can increase the supply from 0 దగ్గర. There is no change. The 0 supply దగ్గర there is no moving the electron and holes, right? But you can increase the power supply. Now you can apply the 2 volts or 1 volt. Small voltage we are applying here. Due to the small voltage, the some few electrons with low pressure can move from P-type to N-type. And similarly, the negative term of the battery we are connecting to N-type semiconductor. N-type is having the charge carriers or electrons. That electron is repelled by the negative term of the battery at low pressure because we are applying to just 2 volts or 1 volt. So now this electron is moving towards at P side and this hole is moving towards P side. Then what will be the junction width? This barrier width. This is the junction. What will happen in the junction or barrier? ఏమవుతుంది barrier లో electron is moving from n type to p type and hole is moving from p type to n type. Then what will happen in the junction? ఏమవుతుంది junction లో? Now I can take the one back here. I am applying some force from this side and I am applying the another force from this side. Then what will happen? Decrease, not constant, decrease. It is along the constant. So now usually this put without applying supply, width is more. Now I can apply the supply. And the hole is moving this side and electron is moving this side. So then due to that movement of electron and holes, the barrier width will reduce. Now we can increase the power supply. Now I apply the 2 volts. Now I can increase the power supply. Again the junction width will decrease. Now I can increase the 3.5. Again will decrease. You can apply the more voltage. Junction will disappear. The junction will disappear. Then the electrons are moving. So holes are moving this side direction, and holes are moving. Electrons are moving from N to P type. So that means the current is passing from N type to P type. The electrons and the holes are moving from P type to N type and N type to P type. So the electron movement or hole movement is there. The current can flow from the device. Okay. So here the diode is not generating the current. The diode is allowing the current based on how we are connecting the battery. Now the electron movement is there or not here in this connection. Is there from N type to P type and the hole is from P type to N type. So the current is allowed from the PN junction diode, and this connection is called, what is the connection? Forward bias. Now that battery and diode connection is called the forward bias. In forward bias, the diode is allowing the current or not? Okay, now. So now the diode is connected in forward bias. The bias is nothing but the applying the power supply to the electronic component. Here the electronic component is diode. So for the diode we are connecting the battery. That is called the biasing. So which biasing we are using? Forward bias. In forward bias, the current, the electron can move from N type to P type semiconductor. So the current is flowing from P to N type semiconductor. Opposite of electron. The electron is moving this direction, electron, and the current is moving this direction, P to N. So now that's why the symbol is P type to anode to cathode. So the current direction is this. Okay, now we can draw this is the operation of the PN junction diode. Now based on this operation, now we'll take the small table for better understanding purpose. Applied input voltage and just input voltage and output current. Battery voltage and current. Now you can say at 0 volts, how many electrons, or just you can tell me the 1 or 2, not like few or more or medium or whatever. Okay. So if you are applying the 0 volts to PN junction diode, so what is the electron current or what is the electron movement from N type to P type? No electrons get put. Okay, that is 0. Now we can increase the 0.1 volt. Electron can move the voltage input voltage in terms of volts. Now I am applying the 0.1 volt. Electron can move? No, because the barrier is there. After applying the 0.1 volt, the junction width decrease. Listen carefully. The junction width decreases. Now we can apply the 0.2 volt, 0, and here also 0. Now we can apply the 0.3. Now slightly will increase 1 milliamp. For example, that means at 0.3 volts, the diode starts conduction. Before 0.3 volts, the diode does not conduct. That means that is acting as a insulator. But at 0.3 input voltage, the diode is uses somewhat current 1 milliamp or 1 practical is there. That's not required. Then you can increase here 0.4 volt. Then the current will increase. And you can apply the 0.5 volt. But again, the current will increase. Okay. At certain voltage, certain forward voltage, this voltage is called the forward voltage because the diode is connected in forward bias. So if the diode is connected in the forward bias, the applied voltage is called the forward voltage, that is denoted as V suffix F. Okay. So now the forward voltage, if you are increasing the forward voltage, the current also increase, and at certain forward voltage, the completely the junction will disappear. There is no more junction here. The freely the electrons can holes can move from P to N, and electrons can move from N to P. So the current, how much current you are applying at the battery, the total current can flow from this battery, this PN junction diode. Okay. Now we can draw the. This is called the VI characteristics based on this table. What is the graph name? 1DR, 2DR, 3D. Huh? Okay. Now, what is the parameter we can take here? What is the parameter here, and what is the parameter? What is the parameter? And here we are having only two parameters. And which parameters we are taking on x-axis? The general graph terminology. The which variable we are taking on x-axis, and which variable we are taking on the y-axis? General graph. X-axis, y-axis. This is the x-axis, and this one is the y-axis. X మీద ఏం తీసుకుంటారు? Which parameter you can take, and y-axis మీద తీసుకుంటారు. Not in terms of here, general. General. For example, I will give the one y is equal to f of t. Y is equal to f of t. Two variables ఉన్నాయి అక్కడ. Y ఉంది, t ఉంది. Y ఎక్కడ తీసుకుంటారు, t ఎక్కడ తీసుకుంటారు? Y on y axis, t on x axis. Why not reverse? Okay. That's not our subject. Now, always while drawing the graph, always you can take the independent variable on x axis. Independent variable. For example, simply input. Input ఏదంటే that input you can take it on x axis, and the output is based on the input value, how the output is varying. That parameter you can take the y axis. Now coming to our PN junction diode characteristics. What is the input and what is the output? Voltage is the forward voltage, is the input voltage. So that we can take. Now, how much voltage you are applying with respect to this voltage, the current is varying. Without applying the voltage, what is the current? No change. You can increase the voltage, the current also increases. You can maintain the voltage constant, you will get the current also constant. That means here this is the independent variable and this one is the dependent. By varying the which variable, the value is changing. That is called the output. And which variable we are changing, that is called the independent variable. So now we can take the independent variable on x-axis and dependent variable on y. The diode is connected in forward bias. So now that voltage, applied voltage is called forward voltage, and current through the diode is called forward current. That is I suffix F. Now, what is the when the diode starts from conduction? At what voltage onwards the diode is starts the conduction? That is the diode is allowing the electrons and holes from the junction from the table 0.3. So here you can take this point 0.1, this one 0.2, 0.3, 0.4, 0.5. Okay. Now, so the diode starts. Suddenly increase the slow now. Slowly it will increase. From the graph, from the table, we are drawing the graph. So here at 0.3 volts up to this, up to 0 to 0.3, there is no current. So that's why we are taking the graph on x-axis. At 0.3 volts onwards, slowly the current is increases. At certain voltage, the complete junction will disappear. Then the total current can flow. So that's why the take that is called the volt ampere characteristics of the PN junction diode under forward bias. Now we can first note down. If you want to note down this, I will give the 2 minutes, and after this, then you can write down the forward bias and again the same diagram. Okay, then you can draw the graphs using symbol. If I have the already known, then simply I will start the continuation explanation. Okay, now okay, now see the diode starts from 0.3 volts. The diode starts conduction from 0.3 volt of the forward voltage for the germanium diode. If the p-type semiconductor and n-type semiconductor are made up of germanium atom, then that p-n junction diode cutting, this voltage is called cut-in voltage. Cut-in voltage. So the each semiconductor element is having its own cut-in voltage. For the Germanium, that is the 0.3 volt, typical value. The practically you will get a 0.2 volt, but the typically that is the 0.2 to 0.3. Okay, so that is the 0.3 volt. And another semiconductor usually we are using is silicon. So the silicon cut-in voltage is 0.7 volt. Germanium cut-in voltage, I will write the V cut-in is 0.3 volt, and the silicon V cut-in voltage is 0.7 volt. That is for objective type and one more questions. So the silicon diode cut-in voltage is the 0.7 volt, the typical value, and germanium cut-in voltage is 0.3 volt. After that 0.3 and 0.7 volt only, the diode will start conduction. Okay. Now, here the practically here only I will explain. Diode under forward bias. If you are increasing the current, if you are increasing the battery voltage, then RF is the forward resistance. The ideal diode, the forward resistance is the 0 ohms. But practically the diode resistance can be defined as, anybody can define the resistance? Okay. But the property of the resistance is it opposes the flow of electron. Now, in terms of the voltage and current, what is the definition of resistance? V is equal to I. You can remove the proportional. You can take some constant R. R is equal to V by I. Vf by If. This resistance is called the DC resistance. The DC resistance is the forward voltage. The resistance simply defined as the ratio of voltage to current. Okay, so which voltage we are taking here? The forward voltage and forward current. So the DC, this is simply called RDC. The DC resistance is defined as the ratio of forward voltage to reverse. Forward voltage to forward current. That is Vf by If. And one more resistance is there. That resistance is denoted as RAC. AC is alternating current. So now this RAC is defined as delta Vf by delta If. What this delta indicates here? Difference value. Difference of forward voltage. How will you get the difference of forward voltage? Higher voltage minus lower voltage. For example, you can take here this voltage and this voltage. This difference is called delta Vf, forward voltage, and forward this difference is called forward current. And this is the change in the voltage, change in the current. So this resistance is called dynamic resistance. The dynamic resistance or RAC resistance, that is defined as the ratio of change in forward voltage to the change in forward current. That is delta Vf by delta If. The delta Vf by delta If, that is called the dynamic resistance. This resistance is called the DC resistance or the static resistance. Means fixed. The practically we are considering RAC resistance for the practical purpose. For the ideal cases, DC resistance. And the ideal case, the diode forward resistance is 0 ohms. Ideal. Where we are assuming this ideal cases, whenever you want to analyze the electronic circuit. In the next coming topic, the amplifiers are there. The common emitter amplifier. Okay, so in the emitter, the many we are connecting the one transistor along with the many resistors and the capacitors and the power supplies. So to analyze that transistors or that circuit, we are assuming the ideal cases. The practical means whenever you are in the laboratory, practically you want to analyze. At that time we are using RES. Okay. Now put heading the PN junction diode under reverse bias. Forward bias, PN junction diode under reverse bias. Now we can take the same here also the construction diagram. Okay. Later I will write this. This is the P type and N type semiconductor. Later I will represent ions, positive ions and negative ions, charge carriers. Okay. Now you can connect the battery. In forward bias, how we are connecting the battery? Don't say the reverse or forward. How you are connecting the battery terminals to PN junction diode? Positive terminal of the battery to P-type semiconductor, and negative terminal is negative terminal of the battery connected to the N-type semiconductor. That is forward bias. Now on the reverse bias, reverse. Okay, reverse direction. Now this circuit can connect the two ways. You can change the diode direction, or you can change the battery direction. Any one you can change. If you are changing the both, what will happen? Again, that forward bias. So you can change the anyone using the symbol. Okay, this is the diode reverse bias. Now, the N-type semiconductor is the charge carriers are electrons, and P-type is holes. Now, apply the voltage. What will happen? This electron is attracted by the positive terminal of the battery. And this hole is already some barrier is there here. Initial barrier, this one. Okay, initial without applying the battery, some barrier is developed. That barrier is this. Now we are connecting the battery supply positive terminal to cathode and negative terminal to anode. Now this anode N-type semiconductor is having charge carriers are positive. Then what will happen? The positive terminal of the battery is attracting the negative charge carriers. So these carriers, electrons are moving this direction. Electrons are moving this direction and holes are moving this direction. I will take the O positive. O positive means holes, E minus means electron. Okay, so the electrons are moving. Now what will happen in the junction? Junction width increases. Okay, now again we increase some level of the battery, then what will happen? Still the junction width increases. This shows the initial battery width. After applying the reverse voltage to the diode, the junction will increase. Enduku increase avutundamma? Why it is increasing? Here you can see and the junction. This is the p type holes and the electrons. ఇక్కడ ఉన్న హోల్ ఇక్కడ మూవ్ అయింది, ఎలక్ట్రాన్ ఇక్కడ మూవ్ అయింది. ఇక్కడ మధ్యలో ఏమి నాకు దగ్గర ఇక్కడ వెళ్తుంది. ఇలా ఫ్రీ స్పేస్ ఉంటుంది. ఫ్రీ స్పేస్ ఏమవుతుంది? జంక్షన్ విత్ ఇంక్రీజెస్. స్పేస్ ఫ్రీ ఉంటే జంక్షన్ విత్ will increase. So that's why in the reverse bias, after moving the holes to negative term of the battery, electrons to positive term of the battery, the free space is developed here. So in that free space, the barrier will spread easily. The barrier is spreading more. That means the junction increases. The junction increases. If the junction increases, any electron or hole can cross the junction. Which is no. So if the barrier increases, the no electron and hole can move from the p type to n type and n type to p type. Then what is the current in the reverse bias? What is the current? What is the current in the reverse bias? No current. What is the current? Current is the flow of electrons. But in the reverse bias, by increasing the junction weight, no electron can move from n type to p type. No hole can move from p type to n type. So there is no movement. Sir, akakchikam both adhika. Why we are studying this? To flow the current from n type to p type and p type to n type direction lo move kaval. But that is not moving from the junction. So the current through the junction is zero. In the reverse bias, the current is zero. Remember. Now, if you are connecting the diode, the current is zero. Then the diode is in which state? On state or off state? Off ante no electron is moving. Fan tirigalante switch on cheyali. On ante enti kada the electrons are moving from switch board to here. So that's why the fan is rotating. If you are switching off, fan will switch off. Fan will stand by position. And similarly, if the PN junction diode is not allowing the current through the junction, then the diode is called the off state. Off state. If the diode is allowing the flow of electrons or holes through the junction, the diode is called on state. Now tell me the one application of the diode. On off. What is the meaning of on off? Switch. Right? So the diode is acting as a switch for some electronic circuits. The diode one application is acting as a switch. Okay, so you can remember that application. Now coming to this reverse bias. If you are increasing the temperature, what is that? In the electronics, if you are increasing the temperature, the electrons will get energy. If the electron is having the more energy, then what will happen? That will move fast. Okay. Now, in this case, in the reverse bias, there is no current through the junction. But if the temperature increases and by moving the electron towards the positive term of the battery and hole towards the negative term of the battery, some temperature will rise. Okay. Due to rising of that temperature, with the p-type semiconductor, how many covalent bonds are there with this n-type semiconductor? How many covalent bonds are there in this p-type semiconductor? 4. Antena? It will name a covalent bonds. 4 covalent. And why 4 covalent bonds? Here 4 covalent bonds and here 3 covalent bonds. Here by increasing the temperature in the diode. ఇక్కడ మీరు డయోడ్ టెంపరేచర్ ఇంక్రీజ్ చేస్తే వోల్టేజ్ ఇంక్రీజ్ చేస్తే బై డయోడ్ గెట్ విల్ హీట్ అప్ డ్యూ టు దట్ హీట్ దిస్ ఆల్రెడీ ఫార్మ్డ్ కోవాలెంట్ బాండ్స్ విల్ బ్రేక్. ఇద్దరు కలిసి ఉన్నారు, మధ్యలో కూడా పుల్ల పెడితే ఏమవుతుంది? విడిపోతారు కదా. సేమ్ హియర్ ఆల్సో ఇఫ్ ద టెంపరేచర్ ఇంక్రీజెస్ ఆల్రెడీ ఫార్మ్డ్ కోవాలెంట్ బాండ్స్ విల్ బ్రేక్. If the covalent bond ఏమున్నాయి? 1 electron two electrons ఉన్నాయి. Okay, now if the covalent bonds are break damaged due to the temperature increases, the covalent bonds will break. Due to breaking of that covalent bond, the free electron hole pairs are generated. And already without breaking, for example, 10 ఉన్నాయి 10 electrons. 10 electrons already move అయిపోయి. Now due to breaking that covalent bonds, ఇంకేమవుతాయమ్మా electron and holes can generate, right? Now here also same electron holes, and here also electron and holes. Listen carefully this point. If you are understanding this point, the PN junction diode working operation you will get the perfect. Okay, now so here electrons and hole pairs are generated, and here also the electrons and holes ఎక్కడ ఉన్నాయి ఈ స్పేస్ లో and here, but here which voltage we are applying? Negative. Due to this negative terminal of the battery, what will happen for this electron ఏమవుతుందమ్మా? రిపెల్ అయినప్పుడు ఏమవుతుంది? that is trying to cross the junction. Listen carefully. So ఎక్కడి నుంచి వచ్చింది ఎలక్ట్రాన్? increase the temperature increase కావడం వల్ల the covalent bonds break అయ్యింది. ఆ బ్రేకింగ్ వల్ల ఎలక్ట్రాన్స్ హోల్ pairs can generated. ఈ ఎలక్ట్రాన్ అంటే ఇక్కడ ఎలక్ట్రాన్ వచ్చేసింది, హోల్ వచ్చింది. హోల్ ఏమవుతుంది? బ్యాటరీ అట్రాక్ట్ అవుతుంది. అంటే యాజ్ యూజువల్ గా ఇక్కడ హోల్ కాబట్టి హోల్ వచ్చేస్తుంది. ఇక్కడ బట్ ఎలక్ట్రాన్ ఏమవుతుంది? రిపెల్ అవుతుంది. సో దిస్ newly formed electron hole pairs, electrons are crossing the junction because this is the repelling, and here also the hole can, this electron can attract here, but holes can move from n type to p type. n type లో ఉన్న హోల్ ఎక్కడ నుంచి వచ్చింది? n type ఉన్న హోల్ ఈ హోల్ ఎందుకు వచ్చిందమ్మా? because increase the temperature damaging the covalent bond, right? normal operation lo here holes are present and electrons, normal operation. Okay, now we are increasing the reverse voltage. This hole can be attracted here and this electron can be attracted here. That's the normal operation. That is the over. Now due to the increasing the reverse voltage, the temperature get heat. Due to that heat, already formed covalent bonds will break. Due to that break, electrons and hole pairs get generated in the n-type semiconductor as well as p-type semiconductor. Now ఇక్కడ ఉన్న హోల్ జనరేట్ అయిన హోల్ లో can be attacked with the negative terminal. ఇక్కడ ఉన్న ఎలక్ట్రాన్ ఇక్కడ అటాక్, బట్ ఇక్కడ ఏముంది? ఇంకోటి మిగిలిపోయినది electron and hole. Now that electron can be repelled by this terminal, and this hole is repelled by this positive terminal. So now the excess electrons and the electron pairs and hole pairs can try to move the junction. Okay, now again still if you are increasing the voltage, current will present or not in the reverse bias? Present. On what basis that current is present? Breakage of covalent bond. The newly generated electron hole pairs, the current will flow, or electrons and holes can move from the p type to n type and n type to p type. That current is called reverse saturation current. That current is called reverse saturation. The current is called reverse saturation current. Okay, now this reverse saturation, for example, the forward voltage is in milliamps, then it may be microamps. The reverse current, reverse saturation current is denoted as I naught. The reverse saturation current is denoted as the I naught, and this in terms of microamps. General forward current is in terms of milliamps, but this is very less. Okay, that current is called reverse saturation current. I will give the one point here for the objective type questions. Here I02 is equal to I01 into 2 to the power T2 minus T1 by 10. What is the I02? The I02 is the reverse saturation current. I01 is the reverse saturation current. The I01 is the reverse saturation current at temperature T1, and I02 is the reverse saturation current at temperature T2. Temperature T2. The T2 is the high voltage, high temperature, and T1 is less voltage. Less temperature. Now the difference between the T2 upper temperature and lower temperature is 10. What will happen? For example, 10 degree, 11 degree centigrade, 1 degree centigrade. 10 by 10. 1 to the power 1, 2 into I01, 2 I01. Okay. Next, 21, 31 degree centigrade and 11 degree centigrade. 20 by 10. That means 2 square. 2 square means 4 into I01. Now, what you observed from this? What you observed? Both I01 and I02 both are reverse currents only. Then temperature increases, reverse saturation current also increases. At what rate? At what rate that is increasing? 10 increase होते हैं तब कमा 2 I01 है, 20 increase होते हैं 4 है, 30 increase होते हैं 6 होते हैं. What's the meaning of that? 6 का 2 to the power 3, 8. So that means every 10 degrees centigrade rise in the temperature, the I02 can be double. Right? Every 10 degrees. First 10 degrees की double होता है. Next 20 कहते हैं 2 into 20 आएगा already 10 40. Okay. So every 10 degrees centigrade, the reverse saturation current will increase, but that's very less. And now, if you are increasing the reverse current at certain voltage, listen, at certain voltage, the junction will break. That voltage is called the breakdown voltage of PN junction diode. At certain reverse voltage, the PN junction will get damaged. That reverse voltage is called the breakdown voltage of PN junction diode. If the PN junction is getting breakdown, then what will happen? Damage అయిపోయింది already device. అంటే దాని ఫంక్షన్ నుంచి వచ్చేసింది damage అయిపోయింది. That is the reverse breakdown voltage. Now take the 5 minutes break and come back first. increases in the PN junction diode, then under P side and under N side, the already formed covalent bonds will break and the free electron voltages are generated. And the electrons can move. That generated electron holes are crossing the junction. That means the PN junction diode reverse bias allows the small amount of current. That current we are calling as reverse saturation current. And after reverse saturation current, if you are increasing the reverse voltage still, then the junction will get damaged due to high temperature. Temperature only we are getting the electron hole break. So the junction will damage. So current suddenly will increase. That is the drawback of PN junction diode. Now you can see the VI characteristics of the PN junction diode under reverse bias. Now where will take the voltage and where will take the current? On x-axis this side. The two sides are there. Here and here. Y and Y. It is for voltage. The which voltage we are applying? Diode is directly same. For the voltage, negative voltage. So then you can take PR, reverse voltage, and we will get which current? Forward current, reverse current. ఇక్కడ ఏముందమ్మా? Hole ఉంది కదా, ఇక్కడ electron ఉంది కదా. Electron how it is moving? Generated electron this direction. So current is reverse direction, means negative current. So IR. Actually the reverse current is 0, but with the increase in the temperature of the diode will get damaged. After damage, the current will increase suddenly. This voltage is called the breakdown voltage of the PN junction diode under reverse bias. That is the VI characteristics of PN junction diode. The VI characteristics of PN junction diode under reverse bias. Coming to the same PN junction diode, the practical purpose is the PN junction diode is the forward bias, and that is acting as a on device. That means the current is flowing. Ideal case. And if the diode is in reverse bias, then the current will not flow. Ideal. Practical here this current and the forward current like this. Okay, so under forward where the PN junction diode acts as a on switch, under reverse where the PN junction diode acts as a off switch. So the diode application is as a switch. The diode can be used as a switch. Now this is the main drawback of the PN junction diode. Under forward bias no issue. After 0.3 voltage, if you are increasing the voltage, the current can, how much current you are applying, the total current can flow through the junctions. No issue under forward bias. But coming to the reverse bias, at certain point of reverse voltage, the junction will get damaged. The junction will get damaged. After damaging, the current will increase suddenly. Okay, that is the main drawback of the PN junction diode under reverse bias. So now we need to overcome. Then we can forward bias we can use this device in any electronic circuits under forward bias. But under reverse bias we can't. Up to limited voltage. Under reverse bias we can use this as a electronic component in the electronic circuits. But after beyond that certain point of reverse voltage, we can't use because the junction is damaging. So we need to overcome this drawback of the PN junction diode. To under reverse bias only, not forward bias. Forward bias is the working perfect, but in reverse bias, they have some drawback. That drawback is the reverse breakdown voltage. Now we need to overcome the drawback. Anybody can tell how we can overcome the drawback? ఎలా వచ్చిందమ్మా ఇది? How we are making the p type and n type? By adding the impurities. Here p type, here n type. Now if you are increasing the impurity level ఏమవుతుంది ఇక్కడ? స్ట్రాంగ్ అవుతుందా? డిగ్రేడ్ అవుతుందా దీని పర్ఫార్మెన్స్? strong. So now you can improve the impurities for the p-type and as well as the n-type semiconductors. You can improve the p-type and as well as the n-type semiconductors. Okay, that's now I can come with the two diodes. That diode is called Zener diode. The Zener diode and p-n junction diode both are same in forward bias. We are not getting the Zener diode for the forward bias of p-n junction diode. Why we are moving to the Zener diode? Because of this breakdown voltage in p-n junction diodes. Okay, that's why we are improving the impurities to the p-type and n-type semiconductor equally. And that diode is called Zener diode. Anyone know down? You can note down. Clearance. Next, put heading. Zener diode also works as p-n junction diode, and the construction diagram also same as p-type p-n junction diode. Only the difference is we are improving the impurities. The impurity level we are improving, and due to the improvement in the impurities, the Zener diode can work in reverse bias also. Okay. And the construction diagram is same. I'm not drawing that. Okay, you can note down this. The construction also same. The construction is same as PN junction diode. The anode. Okay. Now the symbol of this PN Zener diode is same diode. What is the change? Only Z symbol. Reverse Z symbol. Okay, why are you the reverse Z symbol? Because it works in reverse bias. Like that, you can remember the symbol of the PN Zener diode symbol. PN junction similar. Why we are introducing this Zener diode for the reverse bias of the PN junction diode. So that's why you can take the Z reverse. That is the symbol of Zener diode. Now for this Zener diode, apply the positive is same as PN junction diode. The VI characteristics are PF, PF, IF, PR minus IF. The reverse current, reverse voltage, positive current. This is the IM. Don't get confused. IM. Okay. So under forward bias, the PN junction Zener diode, the same as silicon and germanium and silicon. Next, coming to the reverse bias. Correct. Okay, here there is no breakdown. Here the breakdown also will happen, but at the high voltages. Okay, so now this is called the Zener VZ. This voltage is called VZ. Okay, now the simple difference for the PN junction diode and the Zener diode is comparing to the PN junction diode, the impurity levels are improved in the Zener diode for the p-type semiconductor as well as the n-type semiconductor. Okay, by increasing the impurity level, the charge carriers are more for the more at p side as well as the n side. Okay, now the PN junction diode forward bias characteristics and the Zener diode forward bias characteristics are same. Okay, this one also starts from 0.3 volt and 0.7 volt. Coming to the here at the Zener voltage, this voltage is called X Zener voltage. If you are increasing this, if you are increasing the reverse voltage at certain voltage, the voltage across the Zener diode is the constant and current increases. The current increases at certain reverse voltage. For example, the reverse voltage, if you are applying the 0.2 volt reverse volt, here we can the voltage across the Zener diode is the 0.2 volt. And if you are applying the minus 0.5 volts, and here also 5 volts. Now at the 6 volt, the 6 volt. Next minus 8 volt. Here the reverse voltage is minus 6 volt only. If you are increasing the minus 15 volt, the reverse voltage is 6 volts. If you are increasing 20 minus 20 volt, the reverse voltage is 6 volt. What you observed here? Voltage. If you are increasing the bias voltage, if you are increasing the biasing voltage in the reverse bias, the voltage across the diode. How you are measuring the voltage of the component? Volt. How you are connecting the measure voltage using voltmeter. So how you are connecting the voltmeter to the component? Parallel series. కరెంట్ ఎలా ఫ్లో అవుతుంది, ఇలా ఫ్లో అవుతుంది. కరెంట్ మెజర్ చేయాలంటే ఏం చేయాలి, మధ్యలో కట్ చేసి మధ్యలో డివైడ్ పెట్టాలి, అంటే కరెంట్ మీటర్ పెట్టాలి. అప్పుడు ఏమవుతుంది, ఇక్కడ ఎంత కరెంట్ ఉంది, ఇక్కడ నుంచి ఎంత ఫ్లో అవుతుంది, ఆ డివైడ్ ఇంటూ పోతుంది. సో సో టు మెజర్ ద కరెంట్ యు కెన్ కనెక్ట్ ద ammeter, that is called the meter, ammeter, connect in series. And if you want to measure the voltage, you can connect the parallel, voltage across parallel. So now if you are increasing the voltage, reverse voltage, the voltage across this diode is minus 6. For example, I am taking minus 6 volt only. If you are increasing the voltage, reverse voltage, still it will give the minus 6 volts only. What you observe from this? The reverse voltage increases. The reverse voltage through the voltage across the Zener diode is constant. How much voltage you are applying from the switchboard? 230 volts, 50 hertz. Our mobile phone requires how much voltage? 5 volts with 500 milliamps or whatever. Okay, and the 5 volts. అక్కడ 280 వచ్చింది, మొబైల్ ఫోన్ కి ఎంత కావాలి, అక్కడ 300 వోల్ట్ వచ్చింది, మొబైల్ కి ఎంత కావాలి. సో irrespective of the input voltage, output voltage should be constant. That is called regulator. 230 నుంచి can regulate the 5 volts, 240 can regulate to 5 volts, 300 volt can regulate to 5 volts. That is called the regulator concept. Okay, now under reverse bias, the Zener diode is acting as a regulator. That is called Zener regulator. So where you require the constant voltage, then in that you can use the Zener as a regulator. Okay, the concept in the second is the third. Okay, that is the Zener as a voltage regulator. Some regulators are there. This syllabus is not required for you. 79XX. Double X and in this double X place, you can place 5 volts. This is the IC number 7805 IC. That gives the positive voltage regulator, and this is the negative voltage regulator. And then input voltage 10 volt only. If you want only the output is the 5 volt, then you can use the 78XX series. 7805 IC integrated circuit will give the 5 volts output supply by taking the 10 or 15 or 20 any voltage that gives the only 5 volts constant. So this type of ICs are called the voltage regulators. So irrespective of this two regulators, you can use the Zener also as a regulator. Note down. This is the Zener diode. Construction is same. The difference is only you can improve the impurity levels and symbol and the connection diagram. The forward bias is same and the reverse bias only change. In the exam, if you want to explain the GINA, the question like explain the GINA diode working operation, then you can explain the forward bias. How you are prepared for the PN junction forward bias, same content you can write here. For the reverse bias, you can change the content only. So we are improving the impurity levels. So that gives after a certain voltage, that gives the constant voltage across the diode. So due to that, the diode is acting as a voltage regulator. The regulating typical values are between the 2 volts to 200 volts. Depending on the manufacturing of the GINA diode, the regulation voltage is 2 volts to 200 volts. Means 6 and this kunanadi just example matrame. So that range is 2. Depending on the value making of that GINA diode. So practical student we take the one GINA diode and you can measure the reverse voltage. At what voltage? That is giving the constant voltage. Okay. ఇక్కడ కాన్స్టెంట్ వస్తుందో దట్ ఇస్ ద రెగ్యులేటర్. ఆ వాల్యూని రెగ్యులేటింగ్ వోల్టేజ్. నెక్స్ట్, సో దిస్ ఈజ్ అబౌట్ okay, how many terminals are there in the PN junction diode? 2 terminals. What are the 2? Anode and cathode. 2 terminals. The 2 terminals are named as anode and cathode. And GINA diode, how many terminals are there? 2 terminals. That is also same anode and cathode. Okay. Now, how you are applying the how you are getting the GINA diode under forward bias? Connection చెప్పనమ్మా. ఎలా చేద్దాం? Connection. Positive terminal the battery to anode. The p-type semiconductor. Negative of the battery to n-type semiconductor. That is the GINA diode under forward bias. Reverse cheste, you can reverse the battery, then that is the reverse bias. Okay. So these are the 2 terminal devices. Okay, PN junction diode and the GINA diode are 2 terminal devices. Now the 3 terminal devices are there. The devices are called transistor. Now name unnayi terms em unnayama? Tri okati undi. Tran okati undi. Ika resistor. Resistor means resistor. Resistor lo unna word ni last word add chesam. Next transistor. Tri lo unna TR ni తీసుకున్నారు, resistor lo unna resistor తీసుకున్నారు. Okay, so that making the transistor. The transistor means it is transferring the current from high resistance region to low resistance region. The transistor is defined as it is transfer the current from high resistance region to low resistance region, and it is a 3-terminal device. It is a 3-terminal device. Now the general transistor is making is the transistor is how many terminals? 3 terminals. In that 3 terminals also the p-type and n-type semiconductors only. The transistors also made up of p-type and the n-type semiconductors. So PN junction diode, how many regions we are using? 2 regions, p region, n region. That is the p-type and n-type. So transistor no 3 regions, but the 2 semiconductors are there. How you can make 3 regions? You can take the 2 n-type semiconductor, 1 p-type. That is called NPN transistor. Now you can take the 2 p-type semiconductors and 1 n-type. That is called PNP transistors. So how we are making the PNP transistor? Basically, you can take the PNP transistor. So the transistor is NPN. PNP. So how we are making the NPN? General definition by seeing that word, how we are joining the Different semiconductors. మీరు జనరల్ గా బ్రెడ్ అవి తింటుంటారు కదా, ఆ లెవెల్లో చెప్పండి. అంటే డెఫినేషన్ కూడా అలానే ఉంటుంది. బ్రెడ్ జామ్, అక్కడ బ్రెడ్ ఏంటి, జామ్ ఏంటి? You take the P type NPN semiconductor. NPN transistor. Bread ఏంటి ఇక్కడ? N type semiconductor. ఎన్ని బ్రెడ్ తీసుకున్నాం? 2 bread. Jam. Now can define the transistor. Bread jam. Yes. In terms of bread jam, tell me. Okay, then what ఏమంటారు? 2 breads మధ్యలో జామ్ పెట్టేదని ఏమంటారు? కరెక్ట్ వర్డ్ చెప్పట్లేదు. 2 బ్రెడ్ పీసెస్ మధ్యలో జామ్ పెడితే, జామ్ కానీ ఇంకా వెజిటబుల్స్ కానీ అవి పెడతారు కదా, శాండ్విచ్. So the p-type semiconductor is sandwiched between the 2 n-type semiconductors is called the NPN transistor. So the NPN transistor is defined as the p-type semiconductor is sandwiched between the 2 n-type semiconductor is the NPN transistor, and the n-type semiconductor is sandwiched between 2 p-type semiconductors is called PNP transistor. Okay. Now that is the definition of how we are forming the NPN transistor and PNP. Now we can take what are the regions? NO, P, P, NO. If by looking at diagrams, the 3 regions are there, PNP and NPN. All are same. Random but all there. The 3 are same. Are different? No. So which one is the larger? This first year, and this region is called emitter terminal. Why is this the name is called emitter terminal? I will explain later. Now only. Next, this one is this terminal, and which one is the lightly doped? This is the more region is heavily doped. Doping ఎక్కువ ఉంది అక్కడ. Doping ఎక్కువ ఉంటే ఏమవుతుంది? ఏమంటే అమ్మ doping ఎక్కువైతే ఏమవుతుంది? సెమీకండక్టర్ లో doping లెవెల్ ఎక్కువ ఉంటే ఏమవుతుంది? తక్కువ ఉంటే ఏమవుతుంది? p-type సెమీకండక్టర్ తీసుకున్నాము. ఇదొక p-type, ఇదొక p-type. దీంట్లో తక్కువ డోపింగ్ తీసుకున్నాము, ఇక్కడ ఎక్కువ ఇంప్యూరిటీ తీసుకున్నాము. తక్కువ ఇంప్యూరిటీ దగ్గర ఏమవుతుంది, ఎక్కువ ఇంప్యూరిటీ దగ్గర ఏమవుతుంది? Charge carriers are more. The which region is heavily doped, that region is having more charge carriers. And తక్కువ ఉన్నది, so this is the lightly doped and this one is moderately doped. Moderately. Now, how many junctions are there in the NPN transistor and PNP transistor? 2 junctions. What are the 2 junctions? Now you can tell me in terms of this is the emitter and this one is base and this one is collector. Now you can tell me how 2 junctions are there. The 2 junctions are formed between what are the regions? The one region is between emitter and base. This is emitter base and this one is base and collector. The 2 junctions. Now the junction between the emitter and base is called emitter diode. Full ga rayaledu, you can write in the full. Okay, that is called the emitter diode. The junction between the base and the collector is called collector diode. And similarly here also same. Emitter, base, collector. That is the construction. How we are constructing? The 2 p-type semiconductor is sandwiched between the 2 n-type semiconductor, then that can form a NPN transistor. That is the construction. Okay, and the heavily doped region is called emitter, and moderately doped region is called moderate width is called collector, and lightly doped region is called base. Base అంటే ఏంటి జనరల్ గా? బేస్ మధ్యలో ఏదైనా ఫ్లో అంటే ఏదో సపోర్ట్ ఉండాలి కదా, that support is the base. That's why the name is called base. Now why the emitter is called emitter? What the emitter emits electrons. The highly, why it is emitting the electrons? Because heavily doped. Because of heavily doping, that region is emitting the charge carriers. That may be positive charge or negative charge. ఇక్కడ NPN తీసుకుంటే నెగటివ్ చార్జ్, ఇక్కడ తీసుకుంటే పాజిటివ్ చార్జ్. అంటే పోల్స్ ఎక్కువ ఉంటాయి, ఇక్కడ ఎలక్ట్రాన్స్ ఎక్కువ. డిపెండింగ్ ఆన్ ద కన్స్ట్రక్షన్, డిపెండింగ్ ఆన్ ద టైప్ ఆఫ్ ద ట్రాన్సిస్టర్. నౌ so the emitter is emitting the electrons. For example, you can take 100 electrons. Now biasing, shall I connect now only? Okay, now here 100 electrons are there, and here lightly doped 2% of holes, and remaining 80%. 20. Now we are connecting. Identama? Okay, now this is the we are connecting the two batteries. The negative term, the battery one is connected to the positive terminal of the transistor, that is the emitter. The emitter is which type of material is having the n-type? Sorry, n-type semiconductor. Emitter is the n-type semiconductor. Charge carriers or electrons. ఇప్పుడు ఏమవుతుంది? Repel అయ్యే ఎలక్ట్రాన్ ఎలా మూవ్ అవుతుంది? Towards base. What is the base type? P type. What are the charge carriers? Holes. Yes, last pages. Student la kalam ichesar. Okay, now 100 electrons are there. Within this 100 electrons are moving from emitter to base. Listen carefully. Base. The base is the p-type semiconductor. That p-type semiconductor is p-type semiconductor, and that p-type semiconductor is having charge carriers or holes. Now, ఇక్కడ నుంచి ఎలక్ట్రాన్స్ వస్తుంది, ఇక్కడ నుంచి హోల్ ఏమవుతుంది? ఏమవుతాయి? కోవాలెంట్ బాండ్ అట్రాక్ట్ అవుతుంది. అంటే ఇక్కడున్న హోల్ ఇక్కడ ఒక ఎలక్ట్రాన్ తీసుకొని ఇక్కడ ఫార్మ్ ఏ బాండ్. నెక్స్ట్, హౌ మెనీ ఎలక్ట్రాన్స్ ఆర్ యూజింగ్ ద బేస్? 20. ఫర్ ఎగ్జాంపుల్ తీసుకున్నాను 20, అంటే 20% ఆర్ కెన్ టేక్ 20. రిమైనింగ్ ఎలక్ట్రాన్స్ బై ఇంక్రీజింగ్ దిస్ ఏమవుతుంది? బేస్ నుంచి ఇక్కడ కలెక్టర్ వస్తాయా? బట్ వేర్ ఇస్ ద కలెక్టర్ చార్జ్ క్యారియర్స్? Already the electron charge carriers are attracted by the positive terminal of the battery. Next, what about the remaining 80 electrons of the emitter are reaching the collector region? Now collector, what collector is doing? Collecting the electrons from emitter region. That's why the collector, the last terminal is called the collector terminal. And the first one is emitter. Why the name is emitter? Because the charge carriers are emitting to base as well as collector. Okay, so that's why the name, the three terminals are named as emitter, base, and collector. Now, in this transistor, the current flow through the which region charge carriers? Any charge carrier current వస్తుంది? Only emitter. ఇది రివర్స్ బయాస్ లో ఉంది. ఎమిటర్ బేస్ డయోడ్, సారీ కలెక్టర్ బేస్ డయోడ్, కాబట్టి దీని వల్ల కరెంట్ రాదు. current is not flowing, right? అర్థమవుతుందా? ఇది ఓపెన్ పెట్టండి, ఇది ఓపెన్ ఉంది. ఎమిటర్ బేస్ కి నేను బ్యాటరీ ఐ యామ్ నాట్ కనెక్టెడ్. దెన్ I connect the battery to base and collector. ఏమవుతుంది? First of all, the base collector diode is the forward bias or reverse bias? Reverse bias. Reverse bias అంటే ఆఫ్ అవుతుంది. But okay, now ఇక్కడ collector diode is reverse bias. అంటే ఈ collector region charge carriers are not giving the current or not using the flow of electrons, flow of current, but only this 100 electrons are the 20% of electrons are recombined with the base region. Other 80% of the electrons are reaching the collector and collected to here. Okay, so the total current conduction through the using only the charge carriers of emitter region only. Okay, and similarly the p type PNP also, the PNP also same, the same. Now how many junctions are there in the transistor? Two junctions. The two junctions are emitter base junction and the collector base junction. Collector base junction, emitter base junction is called emitter diode and the collector base junction is called collector diode. And you can remember the one point here, the normal working of the transistor, the emitter base should be forward bias and the collector base junction should be reverse bias. That's why I am connecting this is the forward bias and this one is reverse bias. Normal working of the transistor. Okay. Now, that is the construction of the NPN transistor. Now, using these three terminals, how many terminals are there? Three terminals. And using the three terminals, the transistor symbol is yes. Cycle is just for our understanding purpose. I draw the cycle. The cycle is not important here. Only the three terminals. The terminal 1, terminal 2, terminal 3. This terminal is called emitter, and this terminal is called base, and this terminal is called emitter, and this terminal is called collector. The three terminals. Now, how the current is flowing in the transistor? From which region to which region the current is flowing? Emitter to collector. Now what is the direction? Current direction? Emitter నుంచి base unda, base to emitter unda? Emitter to electron direction. Base to what is the electron direction in the NPN transistor? Emitter to base. So what is the current direction? Opposite. Okay, base to emitter. So the current is going to. So this arrow indicates the conventional current direction similar to PN junction diode or NR diode. So the current is going through the base to emitter. And for this, what is the type of transistor? This NPN transistor. And the PNP transistor. Okay. In PNP transistor, what is the current direction? Emitter to. Sorry, here you can take. Here only can take a here. On emitter terminal, you can show the current direction because the emitter only giving the current in the transistor. Due to the emitter terminal, the current is flowing through the diode because of the forward bias. Okay. That is the symbol of NPN and PNP transistor. NPN transistor and PNP transistor. Using this. Now, NPN is no PNP. I will take only one transistor for the remaining topics. PNP or NPN? Usually, you will get the exam in NPN on NPN transistor only. So, I will take NPN transistor. Now, how many terminals the NPN transistor is having? 3 terminals. So, in the 3 terminals, we are dividing into the input terminal and the output terminal. Me side నుంచి చెప్తాను. మీకు ఇది input కదా. Okay. ఇది input, ఇది output. Okay. So now input terminal and the output terminal. Terminal కావాలంటే ఎన్ని ఉండాలా? How many terminals are required? 2 terminals. And output also 2 terminals. So, but we are having only the 3 terminals. How we can make circuit, input circuit and output circuit using the transistor? We are having the 3 terminals, emitter, base, collector. Using the 3 terminals, we need to form a, with respect to transistor, the input side and the output side. The input should have the 2 terminals and output also 2 terminals. But we are having only 3. Then how can we make? One should be common terminal for input circuit and the output circuit. Based on the common terminal in the transistor can be connected in 3 ways. If base is the common terminal, then that transistor is called common base transistor configuration. If the emitter is common, then that configuration is called common emitter configuration. If the collector is the common, the collector common collector configuration. Okay. The common base to common emitter, common collector. That's what in common base, what is the input terminal other than common? What is the input terminal and what will be the output terminal? Transistor configuration. Transistor configurations. Name next. Common terminal and input terminal, output terminal. First, we can take type of configuration. Common base configuration. And the second one is common emitter configuration. Next, third one is common collector. Okay, 3 configurations. For the common base, what is the common base? And for the common emitter, emitter is the common. And the common collector is the common. Now, common base, what is the input terminal? The input now can take the okay, take NPN. Now this terminal is the common for the input circuit and output circuit. This is the input circuit and this one is output circuit. So which one is the common? Common base. What is the input terminal? The input terminal is emitter, output terminal is okay. Now we can connect the, this is called the common base configuration. The next one is common emitter configuration. Now you can take the emitter is the common. Emitter is common. So the common term you can write like this. And this is the output and this is the input. This is the input circuit, output circuit. And here, what is the input? Base and collector. So base is the input and output is collector. And the common collector is the common. What is the input? The input is base, output is. So based on these three common collectors, the transistor can be configured. Configured means can be connected in the circuit in the three ways. One is the common base, common emitter, common collector configurations. The common base is the common, input is the emitter, output is the collector, and common emitter. Emitter is the common, base is input, collector is the output. Okay, and similarly common collector. Now the next one is using these configurations. What is the working operation of NPN transistor under common base or selecting the common concept for the all configurations? Okay. The three, I am not drawn the common collector configuration. Draw the common collector and you can give the input, the common input and the output terminals. The last page splits are not following. It's not a regular class. This is for you only. Okay. Common base, common emitter, common collector. Now, I will take the one construction diagram. Okay, I will take the general working operation for this. NOPN. Okay, now you can take here the charge electrons, and here also electrons, and here holes. Without applying the supply, battery 1, battery 2, the battery negative, positive, and the common factor. This is the base, emitter, and collector. Okay. Now, without applying the supply, here some barrier is present, and here negative, 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 positive, 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 and here also positive. Dotted line, not the straight line. Okay. Now we are applying the without applying the supply. Now I am connecting the power supply. Then what will happen here? The negative term of the battery is connected to the n-type semiconductor. Negative and negative will repel. The electron can move like this. And these electrons are attracted by the positive term of the battery. And this is the reverse bias and this one is the Forward bias. Under forward bias of the emitter junction, the electrons are moving like this, and some of the electrons are recombined here. The sum of the electrons are recombined, means that it can be forming a covalent bonds. That is the recombination. And after recombination, the remaining 80% of the electrons are reaching here. That 80% of electrons are again reaching the positive terminal pair. So the total current using this emitter region only. Right? Now you can take the three configurations. First one will take common base configuration. Simply I will write common base configuration. Simply this is also called CP configuration. Now we can connect the transistor in the CP configuration. The transistor in common base configuration, and its input VI characteristics. The input VI characteristics of the common base configuration. Okay. Now, what the device are required to get the characteristics? Voltage and current. How you can measure the voltage? Voltmeter. How you can measure the current? Ammeter. Now you can connect the ammeter and voltmeter here. Yes. Okay, next. Now, how you can measure the current? So, what is the how you can connect the ammeter in the circuit? See. So now here you can connect the one ammeter. What is the current direction? Base to is the base. Collector. What is the direction? Base to emitter. So the ammeter you can connect like this. So positive and negative. Positive term the battery can connect. Term of the ammeter you can connect the emitter and here. Next. Now voltage parallel. Okay, now you can take the 1 voltmeter here. Now, how it works? By applying the battery voltage. Now you can connect the battery. So what is the battery direction? Normal working of the transistor, the emitter base junction should be forward bias. We get it from everyone. The normal working of the NPN transistor or PNP transistor, the emitter base junction should be forward bias. Now we can connect the battery between the emitter and base. What is the emitter type? NPN transistor. Now, what is the which battery term will need to connect the emitter? Negative. Positive. Next here, also we can connect one ammeter. The current direction is the battery is. Now, what is the voltmeter direction? And what is the collector ammeter direction? Ammeter ela connect cheyalante always from which terminal to which terminal the current is flowing. Tell me. Then in terms of construction diagram, emitter to base or base to collector or collector to base or connected to emitter. Collector to ఇది అయిపోయింది దీని డైరెక్షన్ ఇచ్చాం ఎందుకంటే the current is flowing from base to emitter అంటే ఇలా వచ్చేసింది సో దట్స్ వై కనెక్ట్ విత్ ద సేమ్ పాజిటివ్ దగ్గర ఇన్ అవుతుంది నెగటివ్ దగ్గర అవుట్ అవుతుంది దట్ ఇస్ ద పాజిటివ్ నెగటివ్ ఇక్కడ what is the emitter direction collected to base electrons ఎలా మూవ్ అవుతాయి base to collector move the opposite direction. So like this. And the negative. Now tell me the voltmeter direction. Now everyone remember the voltmeter direction should be same as battery direction. The three configurations, the voltmeter direction should be same as battery direction. The input battery or other batteries. Next, current direction is same as current. Ammeter can connect same as current direction. The current is entering from positive terminal to negative. Okay. Now, so what is the voltmeter? And ulta, if you are connecting the ulta reverse, then you will get the positive unte and negative also. Here negative unte and positive also. Okay. Now, this is the common base configuration circuit diagram. We are missing here some resistor components. So, whenever you are applying the power supply to any electronic component, immediately you can connect the one resistor. Supply connect here. So, where we need to connect the resistor? Here or here. And similarly, here battery is there. So, here you can connect the one resistor. That is the complete circuit diagram to get the VI characteristics of the common base configuration. But resistors we are not connecting any closer. But generally, if you want to connect the practically, you can draw the one resistor here and here. Wherever supply is there, immediately you can connect the resistor. Simply. Okay. Now. Gotcha. So that's 2 minutes. Now, I will now. Now, VI characteristics. How many characteristics will get? Characteristics of voltage current only. We are applying the voltage. We are getting the current. How much current is passing through that junction? That is the current. So the graph between the input voltage and current only. What is the input here? Voltage. Output current. Okay. Now, how many in the PN junction diode and the xenon diode? How many characteristics we got? Forward and reverse. Ikkada how many characteristics will get? How many circuits are there here? Here. Input side, output side. So the input characteristics and output characteristics. If you want to draw the input characteristics, you can take this voltage and this. What is the voltage here? The voltage between which terminal we are taking? Voltage between what are the terminals? PCB connected to base voltage. On this current, if the current is there, that current is called collector junction. Okay, so collector current. Now here, this current is called IE, and this current is called IP. Okay. Now here, what is the voltage here? V. So now the input characteristics between which parameters? Input characteristics between the VI we are drawing the VI characteristics of the NPN transistor under common base configuration. Now to draw the input characteristics, what are the input parameters? To draw the output characteristics, what are the parameters? We are taking on X and Y axis. For the input characteristics, what is the input current? IE, emitter current. What is the output current? Sorry, output voltage, input voltage, emitter to base voltage. Next, current is the output current, and the connected to base voltage is output voltage. Now using this four parameters, we are drawing the input characteristics and the output characteristics. Okay. ఒక పాయింట్ చెప్పండి ఇక్కడ టూ సర్క్యూట్స్ ఉన్నాయి. ఇన్పుట్ సర్క్యూట్ అవుట్ జనరల్ ఇన్పుట్ సర్క్యూట్ ఉంది, అవుట్పుట్ సర్క్యూట్ ఉంది. ఓకే, ఐ వాంట్ అబ్జర్వ్ ద ఇన్పుట్. అవుట్పుట్ ఏం చేయాలి? ఎగ్జాక్ట్లీ యు కెన్ కీప్ కాన్స్టెంట్. మీకు డిఫరెంట్ టెర్మినల్స్ ఉన్నప్పుడు ఒకదాని మేజర్ చేయాలంటే రిమైన్ కీప్ ఇట్ కాన్స్టెంట్, డోంట్ చేంజ్. సేమ్ కాన్సెప్ట్ యు ఆర్ అప్లైయింగ్ హియర్. And if you are measuring the output characteristics, then you can keep the input constant. But in input, the which parameter we are keeping constant, we can get after lunch break. So the lunch break up to 1:30, exactly 1:30 can meet here.